Hey, all you cool cats and kittens. We are really moving full speed ahead now. This is going to be the start of chapter 4. Now, you'll notice right away that we're starting off with 4-5. So we're going to be going in kind of unorthodox, I don't know if that's the right word, but we're going to kind of be going in an order, a sequence that's not really going to match the book as far as like 4-1, 4-2, 4-3, 4-4. But I think this order is going to be very, very good for us. So we're starting off with 4-5. This chapter is called Quadratic Functions and Equations. And now we are going to really now venture into new and exciting material that is Algebra 2, big time. So I guess just so you're not really confused by this handout, the first thing I'm going to do is I'm going to completely ignore that little note. And only because, like I just said, we're kind of going a little bit out of order, but it's not going to be a bad thing. It's going to be more of a good thing. And then this other note, the objective of 4-4 was to factor. Okay, we already took care of that like last week. So we now don't even have to really do section 4-4 because we already reviewed that. And we already sort of reviewed and tried to relearn or whatever all the different factoring, like GCF and unfoil, and hopefully you kind of have a mental grip on how unfoil, there's like the pretty simple, quick and easy unfoil, like just the where you could just immediately find your two bubbles for factors. So again, there's like the quick easy unfoil. There's like the Phoenix method unfoil for the toughies. And then there's like that special case unfoil. But anyway, my point is we already kind of covered all the different factoring. Okay. So we are going to be solving quadratic equations. Before I really reveal what that even means, what is this even building off of from your deep, dark past? I don't know. Some space up here. You may recall a time back when you were more innocent and naive. I don't know. Sorry. I don't know. Let's make it a 9. Like back in 6th grade, 7th grade, I don't know. You might have been given an equation like this, and you were told to solve it. And when an equation is just like this, all you really got to do is get x by itself and figure out what x could equal to make all of this true. Like 2 times what minus 1 would actually equal 9. But like I said, the actual act of doing it, you are just kind of getting the x all by itself. And you end up with that. But this is what you might call a linear type equation. Okay? A quadratic equation is where you have a power of 2 on your x. That's basically, so again, I guess I can't emphasize that enough. A quadratic equation essentially means that now the power on your variable is the power 2. So now look at this. This is about as basic of a quadratic power 2 equation as I can throw at you right now to kind of get your feet wet a little bit. Think about what the solution would be to this equation. You know, what number squared would equal 9? You know, and I hope at least you're thinking, well, 3. 3 squared equals 9. But did you also maybe remember, do you also realize and understand that x could also equal -3? And so what that means is that there's 2 solutions rather than just 1. All right, so get used to that. And that's an understatement, you know, like get used to that there's 2 solutions to these guys. Anyway, so we have this standard form of a quadratic equation, and it goes a little something like that. All right, ax squared, you know, so something x squared plus something x plus something equals 0. And quadratic equations don't have to look like that, but that is what we call standard form, when the right side is just a 0 and your x squared term is over here along with your x term and then whatever regular number. So a quick example of something that fits that form beautifully is this example right here on the paper, right? X squared plus 4x minus 21 equals 0. In this example, your a, which your a is in front of the x squared, your a value here is the invisible coefficient of 1, and your b value, you know, in bx is positive 4. And your c value is -21. So again, like I already said, it doesn't have to look exactly like that. I mean, heck, up here, this equation is definitely quadratic, but it doesn't even have an x term. So technically, this has like a 0x involved, as well as like a 0. I mean, or actually, I tell a lie. If you were to put this in standard form, I might as well write it out, I guess. I don't know, just to emphasize my point. You'd have to move the 9 over to the left side by subtraction, and then you could say that a equals 1, b equals 0, and c equals -9, right? But anyway, the biggest point right now is just that a quadratic equation, this is like the third time I'm saying this, a quadratic equation has a power of 2, right? Now, really quick, this zero product property, which we're going to use a bunch. This property, this truth in mathematics, this very simple fact and concept, says that if a times b equals 0, then we know some certain things are true. So think about it. If something times something else equals 0, well, then what do you know to be true? I'll say it another way. If you have a multiplication problem that equals 0, then what? What has to be true about a and b? What has to be true? Well, I'll tell you. The first number must equal 0, or the second number must equal 0. One of them equals 0. That's the only way a multiplication problem gets an answer of 0. A equals 0 or b equals 0. All right? So that's all like the groundwork being laid out for you. And I think I did a pretty good job, if I don't say so myself. But once again, what I've said so far is just kind of like the groundwork. So now let's get into some real examples. So what if I actually wanted to solve this, right? It's not as easy as this very, very, very basic. Like you could look at a quadratic equation like this and just go, oh my gosh, x could equal 3 or x could equal -3. It's very easy to visualize or just do in your head what those answers are going to be. But when you make equations a little bit more complicated with all these terms, it's not as easy just to kind of know what the answer or answers are. So here's what we're going to do. Oh, and by the way, back since like 6th grade or 7th grade, you would just like get x by itself. I mean, I don't want to go into like, crazy detail or whatever, but if I if I gave this to you and I said, "Hey, take this equation and just get x by itself," you wouldn't know what to do. You'd be stumped by that. I mean, again, think about that. Get x by itself? No, that's a dead end. You know what I mean? So here's what we actually are going to do. When you find yourself in that situation with a quadratic equation, you can't just get x by itself. Here's what we do. First of all, step 0. We're going to make sure that the equation is equal to 0. It's got to be written like this. So I guess in other words, it's got to be in standard form. You need the equation equal to 0. You need the right side of the equation to just be 0. Then the next step is the money step. You are going to factor. So our first example, it's already equal to 0, and now we're going to factor the left side. First, we're going to try GCF. There is none. And so our plan B is to unfoil. And this definitely isn't special case unfoil. It's going to be more normal unfoil, if it unfoils at all. And I don't see any Phoenix number out here, so this is just going to be very quick, easy unfoil. Again, if it unfoils at all. It unfoils if there are two numbers that multiply to make -21, but they also add up to +4. -21, it's got to be a plus and a minus. And they got to combine to be +4. Well, let's just cut to the chase here. +7 and x minus 3. Now, the next step is to set factors equal to 0. Because check this out. Remember up here, this 0 product property? If something times something else equals 0, one of the two somethings needs to equal 0. Oh, this factoring strategy is starting to make sense. That's why we set equal to 0, and that's why we follow that up with factoring. Because if you now have these factors that are obviously now multiplied together to equal 0, then check this out. That factor must equal 0, or that factor must equal 0. I mean, that's just facts, right? The x plus 7 needs to be a 0 in disguise, or an x minus 3 has got to be 0 in disguise. The bottom line is, learn these steps. Set equal to 0, factor, and then set the factors equal to 0. And then lastly, you're going to solve for x. So now you have two very solvable equations. Very solvable. So just like you were back in 6th grade or 7th grade or something, you're going to get x by itself now. So we subtract 7 from both sides and we get x equals negative 7. Over here, we're going to add 3 to both sides and end up with x equals 3. So these are my 2 solutions. All right? Moving on. Just more examples, okay? And so let's see what plot twists may await us, okay? Next example. Hey, it's quadratic, right? I can't just get x by itself. Now, the first thing I need to do is set it equal to 0. Get everything on the left side which gets me this. Adding 15 to both sides, nothing combines, it's just over there now. And now what we do next is factor. Is there a GCF? No, there is not. So we go to unfoil. And oh, if this unfoils, we're going to need to do Phoenix method. So we multiply 2, we slide it all the way to the other end, and that 15 becomes a 30. We multiply the Phoenix number over here on the other end. And now that we have this, we can unfoil the easy way. 2 numbers that multiply to make 30, positive 30 that is, but they also add up to negative 11. Well, that would be obviously negative 6 and negative 5. But we don't want to forget to what? Bring the Phoenix back to life. And once we have those fractions, we reduce the fractions if we can. That divides cleanly. This doesn't reduce at all, and so we bump any denominator left over, we bump it up in front of the x. That's why that 2 went from being there to there. All right? So, we got to keep our eyes on the big picture here. We're not just factoring now, right? We're not just factoring. We are factoring so that we can solve for x. So the next step is to set both factors equal to 0. And now we have 2 very solvable equations. This final answer, lickety-split, gets us, or ends up being x equals positive 3. And once we add 5 to the other side and then divide both sides by 2, what we get is 5/2. So those are my 2 answers there. Example number 3. It's quadratic. Could we just get x by itself here? Actually, we kind of can. Oh, plot twist. Whoa, hold on a second. Yes, we actually can. In examples just like this, okay, you can actually, it's kind of like the exception to the rule. You can actually rewrite this as x squared equals 64, and then just look at this and say, wait a minute, x equals plus or minus 8. That's shorthand, okay, people? Don't freak out, all right? Plus or minus 8. That's 2 answers in 1. But you get it? Like, you actually sort of can get x by itself here. Or, hey, but guess what? You could also factor that, just like the general strategy says. X squared minus 64 does factor. It's special case unfoil, because it's the difference of 2 squares. And so when you factor, you get these 2 factors, and once you set each factor equal to 0 separately and solve each of them separately, you're going to get plus or minus 8 again. So either way, right? Hope I didn't brush over that one too fast, but I don't want to make this video an hour long. So that was a pretty nice plot twist there, if I do say so myself, right? Pretty good plot twist. But for the most part, it's the same strategy. Couple more examples, okay? Example number 4. Can we just get x by itself like we did back in 6th grade or 7th grade? No. So let's move that 8x to the other side by subtracting it. And so we end up with 16x squared minus 8x equals 0. We moved that term to the other side by subtracting it. Okay? And now we look at this, and our strategy is to, once it's equal to 0, what is our strategy to do? To factor. So how the heck are we going to factor that? What's the first method of factoring we always have to try? That's right. GCF. Never forget that. Is there a GCF? What's the GCF? I mean, obviously you could probably tell by my tone that there is, okay? What's the GCF? The GCF is 8x. You can divide an 8x away from both of these terms. And when you do that, what's left over is a 2x minus 1 in the bubble. Because 8x times 2x is 16x squared, and 8x times negative 1 is negative 8x. So guess what? That is now factored. And what do we do? Right, ready? Here we go. Here comes a sort of a mini plot twist, okay? I don't know if I'd call it a plot twist, but pay attention nevertheless. What happens next after we factor? Well, since we have something times something to equal 0, then one of these has to equal 0. So again, what I'm saying is you set both factors equal to 0. 8x equals 0. That's right, you set the GCF equal to 0. The GCF is a factor. Bubbles aren't the only thing that can be factors, So the 2x minus 1 is a factor. So is the 8x. So we set 8x equal to 0. We also set 2x minus 1 equal to 0 separately. And now we solve these both separately. They're both very solvable. How do we solve 8x equals 0? How do we solve that? How do we get x by itself? That's right. We divide both sides by 8. Yeah. And then x equals, what the heck is 0 divided by 8? That's right, 0. Over here, we would add that 1 to the other side. So now 2x is all alone, but then we still have to divide both sides by, whoa. Stop the presses. Started going a little bit too fast for my own good. So now we divide both sides by 2, and we get x equals 1/2. So there's my two answers there, all right? Okay? So yeah, same overall strategy yet again. Set equal to 0, factor that left side, set all the factors you have now, usually both factors, 2 factors, equal to 0. So I guess to kind of take a breath here, just to kind of summarize, you set both your factors equal to 0. It doesn't matter if those 2 factors are both bubbles, because you unfoiled, or it was a GCF factor and a bubble factor. Either way, you set your factors, both factors, equal to 0, and then you can solve each of those separately. Last example. All right, so what do we have here? 5x squared minus 180 equals 0. Well, can we just get x by itself? I'm not going to go into that right now. Let's factor, okay? So is there a GCF? Is there a GCF? Yes, there is. That GCF is 5. If there's a GCF, you should factor it out. So when you divide a 5 away from both terms, from that term you just are left with an x squared, and from that term we are left with a 36, I believe. Alright, so that's where we're at. Now, mini plot twist. This factor right here can factor again. Okay? Sometimes, in case this is the first time you're hearing this, it's very possible. Right? Sometimes you can factor out a GCF and the bubble that's left over can actually factor again. This time, of course, it would have to be by unfoil. Okay? So, and that's something you always need to be on your toes about anyway, all right? That's almost like a must check. You got to always check that. Get yourself in the habit of, after you divide out a GCF, you got to check that bubble to see if it's going to like factor again. See over here in example 4, we factored out that GCF, but 2x minus 1 doesn't keep factoring. After we brought out the GCF, we were done factoring. But here in example 5, guess what? X squared minus 6 is special case unfoil. So there we go. Now we're done factoring. Now we can set all of our factors what a nightmare. Okay, so 5 equals 0? What? No. Sometimes that happens, okay? You're not going to get any answers from setting 5, from setting that factor equal to 0. I'm not going to go into detail right now too much. I'm just saying, like, just bottom line, setting 5 equal to 0 is pointless. You're not going to get any answers from that. Okay? You know, setting 8x equal to 0 was a completely different story. 8x equals 0, you can get an answer. But 5, no. Alright, so 5x equals 0 or x plus 6 equals 0. So that means that x equals negative 6, because solving this for x, you would subtract 6 to both sides. Over here, to solve for x, you would add 6 to both sides. And so your two answers are x equals negative 6 or x equals positive 6. So remember, quick recap. It should only take me like 20 seconds or less here, okay? Quadratic equations. If it's quadratic, that means there's a power of 2. And that usually means that there's 2 solutions. The overall strategy, since you cannot just get x by itself, all right, again, can you just like get x by itself? No. So what you do is you set it equal to 0, if it's not equal to 0 already. Then you factor. And since you have factors that are multiplying equal to 0, you set the factors equal to 0, and then you solve for x. That is overall the summary, okay? I mean, I know there's like a couple plot twists along the way, some interesting example types, you know, and stuff like that, but that's essentially it. This remaining part is about graphing. I am not going to worry about it at least for now. Maybe I'm not going to worry about it, but I'm definitely not going to worry about it for now. So that's it.